Chapter 30, Air Brake Foundation Systems and Air Brake Circuits, Day 2, Video 2, Primary Circuit. So as part of the FMVSS 121 regulations, said that we had to have a dual braking system. So we had to have a primary system and a secondary system. If we have a failure in one of those systems, we still have the other system available for us. So on a tractor trailer, generally speaking, the drive axle brakes are the primary brakes. We get more of the braking action happens over the rear axle. We've got, if it's a dual drive axles, we've got 4 wheel ends out there with 4 brakes to apply the brakes. We've got the load over top of it, whether it be transferred through the trailer to the 5th wheel, to the frame, the suspension, down to the rear axles. So we have a lot more weight over the rear axles to be able for those brakes to actuate properly. So we'll use those as the primary brakes. On our trailer brakes, generally we use the primary circuit to send a routine service brake application out to the trailer brakes, but we do have the ability to apply just the trailer brakes separate of the tractor brakes, and we use the secondary circuit to do that through the hand brake or the trailer brake or the trailer spike brake that's on the dash. So that's one difference we've got between the tractor and trailer brakes. The foot valve or the brake actuation valve, treadle valve, all the same thing. That is the valve that controls the airflow out to the brake chambers for the brake application. So we've got in our primary system, supply pressure is available to that brake valve at all times. When we step on the brake pedal or the treadle, it moves the primary piston inside the valve and allows a certain amount of air to flow through it and to actuate the primary brakes. So looking at the treadle valve here, or the brake application valve, here's the pedal that the driver would step on. And in the state that we're in now, my foot's not on the brake. I've got system pressure available on the supply port right here. So the top half of this brake valve is the primary part of the valve. Primary system pressure is available here at all times. On the other side here is my delivery port. So whatever air flows through this would flow through this port, through the lines, out to the brake chambers and apply the brakes. So in the state we're in now, my foot's not on the brake. We've got springs inside the valve to move this primary piston up in its neutral state. So system pressure available here. On the other side, with the piston moved up all the way, I've got the delivery side is open to the exhaust port, right? So the exhaust port flows down through the center of the valve. So any air that's out in the system at the brake chambers or in the lines coming back would be open to exhaust, right? No braking action happening. So we'd have zero pressure here and system pressure available here. Now I'm driving down the road. I start coming up on traffic, so I need to slow down a little bit. I would push down on the brake valve, right? So we have a mechanical or direct connection between the pedal, right, and the primary side of or a direct connection to the primary piston. So the connection coming through here, as I push down on that pedal, would move the primary piston down, right? So the first thing that it's going to do as that piston moves is to close off the delivery side to the exhaust, right? So that now any air that passes through is trapped in here and would not just pour out the exhaust port. I've moved the pedal down a little bit. The pressure's flowing through around the piston and out to the delivery side. As it flows out and starts to fill the brake chambers, I'm going to build up a little bit of back pressure, right? So what's going to happen is the amount of that movement that I've made with the pedal and the piston, I've got springs here, and now I've got air pressure flowing through and working on the bottom side of that piston, and it's going to continue to allow air to flow through until my spring pressure and the air pressure equals the amount of movement that we've had on the primary piston. All right, so I just need to slow down a little bit. I make a slight brake application, 5 pounds of air flow through it, go out to the brake chambers, and start to apply the brakes. That 5 pounds works on the back side of the piston. The air pressure and the spring pressure equalize with the pressure that's being pushed down the pedal, and the piston will shift into its hold state. All right, so no more air is coming into the valve or going through the valve, and we've still got it closed off to the exhaust port. Right, so we've trapped that air out in the system through the lines and out in the brake chambers. So we've made a 5 pound brake application, and we're in the hold state. It's going to stay that way as long as I've got this pedal pushed down that slight amount. Okay, let's say the traffic gets a little bit worse, all right? So I push down on the brake pedal a little bit more because I want to stop a little bit faster. So I've upset the balance, all right? So the piston moves down. We're still closed to the exhaust, so that air that was out in the system is still trapped out in the system. But I've upset the balance, the piston shuttles down. More airflow comes through the valve out to the delivery side, and the pressure increases, right? Now we're up to 10 pounds of pressure, right? That 10 pounds of pressure is working on the bottom side of the piston until the spring pressure and the air pressure equalize the amount of movement or the pressure we've put down on the brake pedal. Then it will go back into the hold state. The piston will shuttle up slightly, no more air in, and we're holding that 10 pounds of air pressure out in the brake system. And it'll continue to do that until I release the brake pedal. So I'll release the brake pedal, traffic is cleared, I want to accelerate again. I've upset the balance in here. I've got too much air pressure and spring pressure pushing that piston up. I've taken my foot off, the piston is shuttled up, closes off the air pressure coming in, so we've closed off anything flowing through the valve, and then it goes into the exhaust state where the piston is moved up. The air that was trapped in the lines and the brake chambers is now free to flow through the exhaust, and that air pressure bleeds off. I've released the brakes.